YouTube, Woo! Mr. King coming at you live from the studio. Here are the questions for the day. Please pause the video and answer them now. Next, remember, to find out how many neutrons something has, you want to take the mass number, which is the total protons and neutrons put together, because electrons are so light you don't count them. So you take the total mass number, and then you subtract it from the protons, and that'll give you the neutrons. Next, today you'll be able to practice modeling the parts of an atom and distinguish different isotopes. I know saying all that stuff will make you sound really smart, and you can share what isotopes are at your dinner table tonight. So pull up the slides, modeling isotopes for Wednesday, and I'll help you get started. So here's some review. Remember, all atoms contain a proton, which is positive, an electron, which is negative, and neutrons, which are neutral. Okay? For isotopes, there are different versions. An isotope is a different version of the same atom. So basically what makes carbon is the amount of protons. So if something has 6 protons, it'll be carbon. But you can change the neutrons, and that'll still make it carbon as long as it has 6 protons. And isotopes, as you can see, can be very common or very rare. So like, for example, most carbon on Earth, including the ones in us, are carbon-12. And what carbon-12, that word, comes from the mass. So carbon-12 gets its name because it weighs 12, whereas carbon-14 weighs 14. And carbon-12, so you know carbon has 6 protons, so to figure out the neutrons, you do 12 minus 6, and then you'll get 6 neutrons. But let's say for carbon-14, it weighs 14, but you know it'll have 6 protons because it's carbon, so you do 14 minus 6, and then you'll get 8 neutrons. So that's important to know. Isotopes have the same number of protons and electrons, but different amounts of neutrons. That's what's variable. Okay? Next, here's some practice. Carbon-14 weighs 14, and carbon has 6 protons. So how many neutrons does it have? Think about it. And then carbon-13. Carbon-13 weighs 13 AMU, and carbon has 6 protons. So how many neutrons will carbon-13 have now? And this next one, you may recognize from Spider-Man 2. Hydrogen-3 is called tritium. That's just the name for it because it's special. Hydrogen-3 weighs 3, and hydrogen, remember, only has 1 proton. So how many neutrons is tritium going to have? Fun fact for you, tritium is super expensive because it's very rare. That's why Doc Ock was stealing it in Spider-Man 2. He couldn't afford it. Okay, and to do the math, remember hydrogen-3, it weighs 3, and you know one of the 3 comes from the proton. So the other 2 things that contribute to the weight must be the 2 neutrons. So you do 3 minus 1 to get the neutrons. And if you need more help, check out this slide. And remember, protons and neutrons in the nucleus, and then the first ring can only hold 2 electrons, all the other rings can hold 8. Now we're going to start making a nitrogen isotope. I'll do the first one for you, with you, and then the second one is all on you. Okay, step 1, Google the atomic number for nitrogen. Or nitrogen. Nitrogen is 7. It's number 7 in the periodic table. And it says drag the correct number of protons inside the nucleus on slide 12. So I'm going to get 7 protons. And I'm going to do my best to spread them out a bit. And I'm going to make them like a little hexagon here. Doesn't have to be perfectly symmetrical like mine. Not that mine's symmetrical, but just do your best to try and spread out. Remember, the positive don't like other positive. And then, now I have to figure out the neutrons. Find the mass number of nitrogen 14 and round to the nearest whole number. So mass number for nitrogen 14. Whoops. 14. 14.003074. So this one, nitrogen's can weigh 14. Okay. Subtract the mass number, which is 14, minus the protons. So 14 minus 7 is 7. Add the right amount of neutrons to the nucleus. So now I'm going to add 7 neutrons. 1, 2, try and use the space. 3, 4, 5, 6, 7. Okay, remember, it doesn't have to look exactly like mine. I just look for 7 protons and 7 neutrons. Now, the last part is the hardest. Nitrogen does not have a charge, so the amount of electrons equals the amount of protons. The inner ring can only hold 2 electrons. The rest of the rings can hold up to 8. Drag the right amount of electrons on the rings and spread them out on slide 12. So remember, nitrogen doesn't have a charge, so we want to balance out these 7 pluses with 7 minuses. So the 7 electrons. And it's usually custom to put the first 2 in the ring. Now, try and spread out the other 5. Remember, electrons repel each other. I can spread them out better. So when I check this, I'm looking for 7 electrons, 7 protons, 7 neutrons, and then 5 electrons on the outer ring, 2 on the inner ring, or orbital. You have to figure out the nitrogen 15 isotope by yourself, and then answer this last question on the last slide once you made both models. After that, please take the attendance survey for Wednesday, and then you're all good to go. Thanks, everyone. Bye.